that they would like to do the recording instead, feel free if anybody ever wants to do it, but I really don't mind doing it. So.
Oh, I'm good.
Okay. As long as
I'm good too.
If I knew how to do it, I'd offer.
Oh, you're
Yeah.
fine. Group ones where they actually made each person. Somebody felt very adamant that it wasn't fair that somebody had to upload the video every week.
Really?
And I was like, are you being for real? I was like, I feel like that's a little ridiculous, but
Yeah.
whatever.
Weirdos.
Those people that think everything has to be equal. Gosh.
One of those, yep.
Who does that? Who thinks who believes in strengths and weaknesses? Come on.
I have a couple kids like that are fairness kids. Everything has to be equal.
Yeah, I have a nephew like that. And he thinks my niece had asked for a pair of sunglasses yesterday that happened to be my sister-in-law's. And she had asked to wear them, and they were in our car. And my nephew goes, well, she's had them for like 5 minutes. It's my turn. And I'm like, dude, they're not even your sunglasses. It happens.
Yep.
Okay, so number 3, I know that the HO has to do with one or more. So does that mean it's true? I know
True.
Yeah. I know the other one means all are equal, but this one's one or more.
Yeah, so the null hypothesis for the ANOVA testing is all means are equal.
Mm-hmm.
So if we have sufficient evidence telling us that one mean is different, then we reject the null hypothesis.
3 is true. And then 4, I started looking at this a little before the quiz. Before we got on. I think it's 2 and 3.
Mom, it's Daddy.
Yeah, I'm not sure. I think it's 2.
Because the readings.
I'm not sure about
There are 2 requirements of ANOVA that must respect. 1, the data are normally distributed in each group, and 2, the variances are equal for each group.
Okay, great.
So B and C.
Okay. Okay, group. Each group to the following.
C.
C.
I say C as well.
Okay.
I remember that.
Okay.
And 6 is B.
Yeah.
Okay.
Is it B or C? 4 times, yeah, I see it. Okay.
4 times.
Yeah, if the largest variance is less than or equal to 4 times the smallest variance, then we will conclude the variances are equal. Okay. Is
that a trick question?
Okay, so there's 3 samples. How many pairs? Isn't there only
4?
Wait.
Or is this a trick question?
Because there's 3 samples, and if there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples? So is it 4?
Or is it all combinations of the 4 different samples? So if you have 1, 2, 3, 4. You compare 1 and 2, 1 and 3, 1 and 4.
Would it just be
Am I
2?
overthinking this?
No, I think that because if I think about it, with 3 pairs with 3 numbers, you can only do 1 and 2, 1 and 3, and then 2 and 3. So there's only 3 pairs. But when you have 4 variables, the number of pairs that you can have goes up because you obviously have 1 and 2, 1 and 3, and 1 and 4, but you also have 2 and 3 and 2 and 4, right? So there's 5. Is that right?
Well, I think it works like it goes 1, 2, 1, 3, 2, 3, and then maybe 2, 4. That's the pattern I'm seeing.
And then
What
4,
about
3.
3, 4?
Yeah, 3, 4 would be one. So that'd be 6 pairs.
Oh no, that would be 5. I think.
1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4.
1, 2, 1, 3,
Oh,
4, and then 2,
no.
3, and 2, 4. Are we missing any?
I think it's just 4. So you see, if there are 3 samples, there are 3 pairs. So these are pairs, right? So there's 1, 2, 3. So I think the answer for this might be 4. That's
Okay. Well, we can try 4. If not, then it's 5 because that's the total number of pairs you can make with numbers 1 through 4, right?
okay.
I got 6, but
Wait,
yeah,
okay,
I
what
think
am
it's
I
either
missing?
4 or 6.
1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, and
3 and 4.
3, 4. Okay. So let's put 4, and then if that's wrong, then we know it's 6.
Okay.
Yeah, we can try 6 too.
Let's try 4. Totally all for that. That's fine because we know that there's only 2 options, so that's 100% okay with me.
Okay.
Okay, do we need to put it as 4.000?
No, I think it would tell you if you needed to do.
Okay.
That's the next question tells you the decimal point.
Okay.
We gotta open up that file and use the ANOVA.
And we would be lost without this spreadsheet, I feel like. Or at least I would be.
Totally.
I agree.
So do we put A in column 1, B in column 2, C in column 3?
Yeah, that's what I'm doing.
Me too.
Don't forget to delete what might already be in
Oh, yeah.
column 6 or variable 6.
Socks are not a variable, or are they?
No, it just says A, B, C, D, and E. And also just wearing the 6.
Okay, so we do want to count.
Do that, yeah. Good catch. The one you did in the homework earlier, you didn't do that one.
Yeah. Okay. So
27.2, is that?
Yeah, 27.208.
yeah, that's what I got. And then 53.158.
Yep.
Is that true or false?
So it has to be,
Because they're not equal.
or is this where you do that formula that it's largest variance is less than 4 times the smallest variance? Or is that
Oh,
something
yeah.
else?
If the largest variance is less than or equal to 4 times the smallest variance, then we would conclude that the variances are equal. And that is true because it's less than.
Is it?
Oh, no, it's greater than, so false.
Yeah, because okay, so just a dumb question. So we're saying that since 4 times 27.2 is greater than 53.158, we're saying it's false.
Yes. Because in the reading it says the variances are equal for each group, and the rule we use is if the largest variance is less than or equal to, if the large is less than or equal to 4 times the smallest variance, then we will conclude that the variances are equal, and it doesn't fit that parameter, right?
So that's why it's false.
Right. So I've forgotten how to do a QQ plot.
That's in that other worksheet, the quantitative descriptive statistics one. There's a QQ plot work or tab. We have to do it 6 different times.
Okay.
Oh,
Greg, do you want to take the first 2? You want to take 3 and 4, and I'll take 5 and 6?
yeah. Let's do it.
Forget when you copy and paste it into the thing, you have to organize the data in this descending order.
That's right. Okay.
When you copy and paste the data into the QQ plot thing,
Yeah.
you have to sort it from lowest to highest.
Oh.
Otherwise, it's just kind of a random plotting of numbers.
And this is a really dumb question, but where is the sort? Oh, sort and filter. There it is. It wasn't showing up. My thing wasn't big enough.
So the first 2 are normal.
Normal meaning that it pretty much follows a straight line, right?
Correct.
And the middle 2 are normal as well.
Okay, let me just do this last one.
No pressure, Alex.
Like pressure, guys.
No pressure to be normal.
It's fine. Yeah, they look pretty normal to me. I mean, there are a few like that vary above it and below it, but overall, I would say the plots are the same.
Okay. we're going to say that one's true. Each of
Good thing we have a 50-50 shot.
What is SPSS? I feel like I know what that is, but I don't.
I think that's just what it is. Because the one on the ANOVA, the p-value is 0.081. And then it says to remove the SOX data, so the sixth one, and then see what it says.
0.309.
Yeah, that's what I got
Oh, wait,
too.
I'm sorry, I'm confused. So we're using the one we've already done, but
Yep.
we're just taking out the sixth variable.
Yep.
Mhm.
Because it's saying, hey, notice that the p-value when all the data is there is 0.081, and then we take out the sixth data, it gives us a different p-value.
Did you get 0.309?
Yep. Okay, the p-value for the ANOVA test is the area in the right tail.
Yeah.
Okay.
So we have to do calories first.
Okay.
Do I want to know what the difference between beef and meat is?
Yes.
Meat is whatever they had laying around.
Probably. Okay, so what are we looking for?
Looking to see if they are normal along the QQ plots. Calories. And they are. They're normal enough, I guess. So, but I don't know which one to
Did you
pick.
take out the rest? Because there was a lot more meat than there was poultry.
Yeah. I think it's the first one, but I don't know about the last sentence of the first one. Actually, I think it's the first one because that's the only positive statement. The assumptions have been met.
Okay. How do we know if the variances have been met, though?
Because of the shape of the QQ plot.
Okay.
If they're all normal, then it assumes that they're all normal.
Yeah.
And so
Okay.
if one of them was, S-shaped or something.
Bailey, do you agree? Because I don't know.
Yeah.
Sweet.
Yeah, I agree.
Now we're on sodium. Wait, no, we're not.
Wait, what's 15 then?
15 is we have to plug in this data for calories into the ANOVA one.
Okay. That's what I thought. I was like, wait, we're not on sodium yet, are we?
Yeah, no, that was the next one. Sorry.
There you go, jumping the gun.
So we're saying A
For 14,
14.
I think so, yeah. Okay.
Well, what is it asking us? We should find freedom 2.
I got degrees of freedom of 1 and 52.
If you delete all the data and the other variables, you should only have 3 variable columns.
I only have 2.
There should be one for beef, meat, and poultry.
Oh, so we count beef and meat. The beef and meat one is 1 as well.
No, they should be separate.
I
You should
know.
have calories for beef, meat, and poultry. So you should have 3 variable columns.
I'm confused. So what goes in variable 1?
Variable 1 would be beef. Calories for beef.
Okay. Variable 2 would be calories.
For meat.
Oh, calories for meat. Okay. And then variable 3 would be sodium for beef.
No, it would be poultry for calories for poultry. You see how the type in column A, there's 3 different things.
We're good. I'm fine. Sorry.
Not that I don't know what the difference between beef and meat is, but maybe it's pork product or something. I don't know.
Yeah, sorry. I just didn't see that. That's my bad.
It says mostly pork and beef, but up to 15% poultry.
Sounds delicious.
Gross.
Yeah.
So what conclusion? So I would say that since the p-value is less than the level of significance, that we would reject the null hypothesis.
Mm-hmm.
And what does that mean with regards to this question?
So I think it's D.
We have sufficient
Because we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than the others. Because, I mean, beef and meat are roughly the same. I mean, they're just 2 points away from each other. Whereas the chicken is like 40 points away. That's just what I think.
I agree with that statement.
Yes, so the book says that these ANOVA ones, the null hypothesis is that everything's equal. The alternative ones is at least one of the means differs. And since we had a p-value lower than the level of significance. Okay, yeah, I like D.
Okay. All right, sodium.
Sorry, I had to talk myself through that one.
No, you're fine. I appreciate that because I wasn't sure if I understood it either. That's fine by me.
Construct these 2 plots of sodium.
guys get that beef was normal? It looks like a lot of them are above.
Yeah, I think it's close enough. Hmm.
Yeah, they're normal.
Yeah. So the assumptions have been met, so A.
No, I'd say they have not been met because
We
aren't they
can't
sort of
assume.
suggesting that the poultry data was not normal? And when you do, let's see.
Hold on.
What was the other test if the largest variance is greater than, how did that one work? The largest variance.
The largest
not
is greater than 4 times the smallest variance. Then they should all be equal.
Okay, so it is in this case. So maybe it is A.
Okay.
Maybe I just don't understand the.
No, you're fine.
I always felt like the Q plot thing is totally subjective.
Well, and here it says, despite the possible problem with the
Yeah.
possible problem with the QQ plot for poultry, you decide to use the ANOVA to determine if the mean sodium levels are the same for all 3 groups. So I think we're okay,
Okay.
based on at least that statement.
Yeah, that makes sense. That's a good deduction.
Okay. So the means are not the same. P-value, I got 0.179.
Me too.
Is that what you got, Greg?
I got a different number.
What did you get for the p-value?
Do you have 0 as one of the values for variable 3?
No.
What do you have as the first value for?
430.
Yeah, now I have what you guys got.
Oh, good.
Okay, I deleted that somehow, sorry.
Oh, you're fine.
So 1.79, right?
Yep, 0.179. Would we say C?
think it's B.
That they have? Oh, we do not have sufficient evidence to reject the claim that all three, but they don't have the same.
Yeah, so the null hypothesis says that all three are the same. So we rejected the null because the p-value is greater than the level of significance.
But we only reject the null if the p-value is less than the level of significance.
True that. So all the means are equal. Choose one of the means.
Okay, hold on. Yeah, I say B.
We do not have sufficient. Okay, I like that one.
Okay. See how we did. 18 out of 20. We missed
That's
10.
still an A.
I know, right? We missed 10 and we missed 7. Do we want to go back and redo it really quick?
I could use the points.
Okay. I'm fine with that.
Which ones? I got 7 wrong too.
We missed 7 we got wrong this year.
Oh, 7 and 10, yeah. Well, let's do that because those ones are easy to fit.
Yeah, let's do that.
No.
I'll read off the answer. Okay. Okay, so for 3, the answer is true. 4, the answer is 2 and B and C, or 2 and 3. 5 is C. 6 is B. And then 7, we got wrong.
They would go with 6. That was, remember we were,
Yeah,
we thought it was either 4 or 6.
Yeah, so let's go with 6. Okay. 8 is going to be 27.208. So 27.208. Okay, and then number 9 is going to be 53.158. So 53.158. Okay, so 10 we got wrong, so it was false, but it needs to be true. Okay, 11 is true. Okay, 12 is 0.309. Okay. 13 is right. Okay. 14 is A, the assumptions have been met. 15 is D. 16 is a 17 is 0.179. 0.179. 18 is B. And that's it.
B?
Yes. There's 100. Cool. All right. Is everybody still good to meet 8:30 on Wednesday to prep for the test?
Yep.
Okay. Cool.
Wednesday it's 6:30?
7:30 your time.
7:30 my time. Okay. And so we should do that and then take the test, right? That's how.
I would, yeah, because well, the test isn't open till Thursday night.
It opens or it ends at Thursday night?
It opens Thursday night.
Oh, okay.
And it ends Saturday night.
Okay.
It's kind of dumb that it's only open from Thursday at 11 p.m. until Saturday at 11 p.m.
Okay.
I'm like, thank you for taking my weekend.
Yeah. Bailey, the other thing we talked about before you came on with is our final project.
Oh yeah.
Maybe to be thinking of like a question or two that we could pick around. Maybe about food.
We threw out food.
Something about food.
I'm fine with that.
Yeah, let's maybe stick with that and think about what we could do as far as like questions to ask about food that could deal with numbers or something like that we could get some stats for, whether we take them ourselves or we can go out and pull like this class. I don't know. So.
Okay. Or we could do prices as well. Something.
Anything. Cool. All right. Well, thank you guys. We'll see you later.
Yeah, we live in 3 different states. We could do pricing for a gallon of milk or something. I don't know.
Yeah, we could do that.
Yeah.
And we could even do like different stores, so we could have different variables between each one. So it could say, hey, what's the average price of, so the mean value of milk, so we could each go to like 5 different grocery stores or something.
Yeah.
Mm-hmm.
That might be a good idea. So yeah, let's think about that.
Yeah.
Okay.
All right. Thanks,
Cool,
everybody.
Yeah. See ya.
See you guys.
Bye.